So if there was a vector diagonally, you break it down in this direction, vector B, which provides the sense of direction. Then this long vector, which I put in blue, is called a projection vector. It is a multiple of B. That's the first thing to remember because they are parallel. Then write the formula, projection vector, which is over here, lambda B. Lambda is A dot B over modulus of B squared multiplied to vector B. Long story short is that lambda is A dot B over mod B squared. Okay, let's give a bit more detail. Can you help me describe this vector pointing downwards using vector A and using lambda B? How would you add them up? Alright, and then inside this diagram, I'm going to start to describe the perpendicular. That this vector is perpendicular. You can either say perpendicular to lambda B or perpendicular to B is the same information. So for simplicity, we're going to be perpendicular to vector B. When two vectors are perpendicular, there's some special algebraic property. So dot product equals to 0. And our task is to find this lambda because that's why we want to know the expression for lambda. And therefore, what we're trying to do here is to isolate lambda. So the first time I distribute, negative A, distribute over to B. Then I continue here, plus lambda, a vector B1, B2, B3, dot product with itself. Thank you. Then B3 squared. A separate independent result, a result on its own, how to calculate the magnitude of a vector. We do Pythagoras theorem here. Yeah, square root of x squared plus y squared plus z squared. So basically, isn't it the above with a square root? It just so happened that the definition of a dot product and using Pythagoras theorem to calculate the magnitude of a vector. For some reason, there's some coincidence going on. So if that's the case, wouldn't you agree with me? If I square, then I can drop the square root. B dot B is the same as modulus B squared. Why did that happen? We define a dot product to be x times x plus y times y plus z times z. This is just an operator. Then this is to calculate the length of a vector. We use Pythagoras theorem, so x squared plus y squared plus z squared take a square root. Then we realize that they're the same thing. B dot B becomes modulus B squared. 0. And last step, make lambda subject. It will be positive of A dot B divided by mod A dot B over mod B squared. Where did it come from? It came from something very solid. It came from the fact that if you want to find this projection vector, it has to be this diagonal. You break down into horizontal, vertical first. Vector A can be like this, and then it can be lopsided, right? If it's lopsided, you would not see perpendicular. Yeah. So if you don't satisfy the perpendicular, whatever expression you have here, it wouldn't really be called a projection vector. It would be too long or too short. It will be the correct length, which means it will be the correct lambda if you satisfy dot product equal to 0. But when you satisfy dot product equal to 0 and you work out the equation, you will get lambda precisely equal to this amount. That's why it looks weird, because it's trying to satisfy the perpendicular. But after the long story, after the drama, you go to the exam also, it's memory work. Are you going to derive this on the spot? You're not going to derive it on the spot.